Right-angled trigonometry intro. As you know, there are lots of different types of triangles: isosceles, equilateral, scalene. But if a triangle has a 90-degree angle inside it, then it's called a right-angled triangle. We will abbreviate that name to RAT from now on. So we know that an equilateral triangle has 3 equal sides and 3 equal angles, all of which are 60 degrees, to give us the 180-degree total. So we can't have a right-angled equilateral triangle, but we can have a right-angled scalene triangle. That's where the 3 lengths are all different. And you can also have a right-angled isosceles triangle. An isosceles triangle has 2 sides which are equal in length. You've met right-angled triangles before when doing Pythagoras, which only works in a right-angled triangle. Pythagoras is all about using the special connection between the 3 sides of a right-angled triangle, but doesn't worry about the angles. Now we are going to move to trigonometry, which looks at the special relationships between the sides and angles within a right-angled triangle. As you know, there are 3 sides in a triangle, and today we'll learn the special names for these sides in relation to an angle. So here we have a right-angled triangle with the right angle just here. We know the side opposite that angle is the hypotenuse. We did this when we were looking at Pythagoras' theorem. So the side opposite the right angle is the hypotenuse, and that's the longest side of the triangle. Now, if we have another angle under consideration, then the side that is next to that angle is called the adjacent, and the side that is opposite that angle is called the opposite. If we switch to looking at the other angle, then still the adjacent is next to that angle, and the opposite is opposite that angle. Once we recognize the sides, there are 3 special ratios that link the 3 sides and the angles. You will be given these on a formula sheet, perhaps. Not necessarily. You should really know them. So, sine theta is the opposite divided by the hypotenuse. What we mean by that is, let's say we have a triangle that we know is right-angled, such as the 3, 4, 5. If we're looking at this angle, then we know that this side is the opposite, this side is the adjacent, and of course we know the longest side opposite the right angle is the hypotenuse. So, the sine of theta here, this angle being the theta, is the length of the opposite, which we can see is 3, divided by the length of the hypotenuse, which we can see is 5. Then the cosine of theta is equal to the adjacent over the hypotenuse. So cos theta in this case would be 4 over 5. And the tangent of theta is the opposite divided by the adjacent. So tan theta here would be 3 divided by 4, 3/4. Remember the mnemonic. It tells us everything we need to know because the order of the letters helps us remember exactly what happens here. We have SOH, S-O-H, and that stands for sine is opposite divided by hypotenuse. We have the cosine. Cosine is the adjacent divided by the hypotenuse. So the order of the letters tells us everything we need to know about these ratios. The tangent is the opposite divided by the adjacent. So katoa. Don't ever forget that, because although it says up here it might be on a formula sheet, or it will be on a formula sheet, you really need to remember it because it's not going to be on a formula sheet going beyond year 9. When working in year 9 in trigonometry, you need to make sure your calculator is in degree mode, as anything else will give the wrong answers. It will give some very funny answers at times. A quick check that you can always do is to evaluate sine of 30, and the answer should be 0.5 or a half if you are in the correct mode. If not, you need to change to degree mode. If you get a different answer, you're going to need to change that calculator mode. So why might it be in the wrong mode? Well, let's say somebody in an older year group has used your calculator. There are other ways of measuring angles other than degrees, and they may have changed to one of those other methods. So you need to make sure that you are back in degree mode, because in year 9 you're only going to be working in degrees.